Hello everyone, hope you are doing good. In the previous video about networking basics, I discussed about you will get an wireless device, wireless router from your ISP, and this particular wireless router will have some Ethernet ports in this particular device. And also I mentioned whatever inbound traffic it is going to do, it will be at layer 2, and whatever outbound traffic it is going to do, it will be L3, which is at network layer. And the Ethernet ports, whatever which is available in this device, it can be used to cable the computer or your laptop. And this can use the wireless connection to connect to this router. And once it connects to the router, you will be able to access the internet via the outbound network access. Because this particular router has public IP address, using the public IP address, it will be able to communicate with the outer world. So there is also a functionality of layer 2 addressing and also layer 3 addressing. Okay, for layer 2 communication, we have either the wireless connection or the wired connection. Because this particular router is also acting as a DHCP server, we will get the IP address from the router. Apologies for my writing. I will get the IP address from this particular router. The IP address, whatever you are getting from this router, it will be private IP address. This IP address will be private IP address which you will get. And also you have an option to configure from which range of the IP address you can use for the DHCP to lease the IP address. You can manually configure this particular router from the console and set the IP address, whether it is a class A IP address or class B or class C. You can use the console and set what is the range of IP address and what is the class of IP address and how many IP addresses can be assigned from this device. You don't want to make the router to assign thousands of IP addresses to your neighbors and other people's, right? So you need to limit the number of IP addresses which can be assigned from the router. So it can be set at the router itself. The console is provided. You can set the IP address from the console itself. And if the number of users in your home is limited to, say, for example, 10 or 5 people, you can only assign 5 IP addresses from that particular router from the DHCP lease. So once you configure the IP addresses which needs to be leased by the router, it will start assigning the IP addresses. For example, if I take 192.168, because in most of the home routers, what we see is this is the range of IP addresses what is being used, and the default subnet mask will be 255.255.0. So if this IP address, so this computer is getting 11, this will get 12, and this will get 13, and this will get 14 from the range of IP addresses whatever you have configured on this particular device. So coming to the IP addresses, there are two types of IP addresses which are used. One is IPv4 and the other one is IPv6. IPv4 is the one which is extensively used in any of the legacy networks and also in the cloud networks. Whenever you see an IP address is a 32-bit octet. So this will be 8-bit and this will be 8-bit and this will be 8-bit. Each bit can be turned off or on. So it can be either on or off. So this particular bit, whatever you are seeing, this can be either 1 or 0. So when you add 8 plus 8 plus 8 and 8, it will be 32-bit octet. And IP addressing has two parts. One is IP and the subnet mask. When you see an IP without subnet mask, it will not be used. This subnet mask is the one which decides how many hosts and how many networks can be created using a particular class of IP address. So in this case, this is a class A IP address, and if I write this particular IP address in terms of decimal, this will be 10.0.0.0 network. And this subnet mask is 255.0.0.0. As I said, the subnet mask is the one which decides how many network a particular class of IP can have and how many hosts can be used in this particular network. So for class A network, this part will be the network and this part will be the host part. So in class A, this part decides on the network and this part will decide on the host part. And the subnet will be always 255.0.0.0 for class A IP range. This is the default subnet mask. This is the default subnet mask what a particular class A network should use. And since this entire range is for the host part, there are possibility of 16 million IP addresses. So we can have 16 million IP address for the host. So we looked into the class A IP address. Now let us look into the class B IP address. This is the IP part and this is the subnet mask for the class B IP address. For the subnet mask, it will be 255.255.0.0. This is the default subnet mask. And the IP part starts from, since this is in binary, this is equivalent to 172.255.255.255. This is just an example. So this will be the network part and this will be the host part. For class B IP address, you can have a maximum of 65,000 and odd IP addresses, and for the network you can have more than 16,000 networks. So this is the one which is deciding on how many networks you can have and how many IP addresses you can assign to a particular host in this class B range of IP address. We looked into class A IP address and class B IP address. Let us look into the class C IP address. So this is 192.168.0.1 and this will be 255.255.255.0. So in class C IP address, we have this IP address and we have this subnet mask. This part is deciding on the network part and this part will be deciding on the host part. So since the entire part of this range of subnet mask decides on the network, and this is deciding on the host part. So maximum we can have an IP address of 255, which is starting from 0 to 255, and there can be over 2 million networks. So in class C, the number of networks are more and the number of IP addresses for the host is less. And this is in binary, which is equivalent to 192, and this is equivalent to 168, and this is 0, and we have 1 here, this is 1. These are the ranges for class A, class B, and class C network which can be used. This is the full range what has been given. And in class A, we can have 128 networks and total of 16 million plus host. Whenever I say host, it is not only the host like laptop or desktop and servers. It is also the networking devices, IoT devices, and other devices. Even for printers also, you will assign the IP addresses. For class B, there can be a total of 16,384 networks and 65,536 hosts can get their IP address. For class C, these many networks can be created and a total of 256 IPs can be assigned to the host. So this is the complete range of IP addresses which can be used. But can we use all these IP addresses in our private network? No. We cannot use the complete range of IP addresses in our private network because there is something called as public IP address range and private IP address range. Public and private. So what exactly the IP ranges which are used by public? Whichever IP you don't see, whichever IP ranges you don't see here, everything will be used by public apart from the reserved IP address range. So what is the difference between a public IP address and the private IP address? These IP addresses are not routable in the public domain. So it is only used in your private network. The range of IP addresses which you are using in the class A, class B, or class C, if you are using from this range, then it is a non-routable in the public domain. Whenever you are going to create network for your enterprise, then you will be choosing the IP ranges from these private IP address range. You will not be using the public IP address range because for private IP address, it has been clearly defined what IP address range has to be used for your private network. So when you are going to create a virtual network in Azure, you will be able to use these IP addresses from any of these range. From class A, you can use these range of IP addresses, and for class B, you will be able to use from these range of IP addresses, and for class C, you can use from these ranges of IP address. When you are going to create a virtual network in Azure, and when you start defining the subnet, for each subnet, you will not be able to use 5 IP address. The one of the IP address is network address and the other IP address is network broadcast address. Even if you are going to use any of the range of IP addresses, you will not be able to use these 2 IP address, whether it is a traditional network or Azure virtual network. And there are other 3 IP addresses which are reserved by Azure. This is for gateway, and another 2 IP addresses are reserved for Azure DNS IP. So the private IP addresses which can be used by Azure Virtual Network or in our own enterprise network, this has been defined under RFC 1918. So if you check the RFC page, this is exactly the same IP addresses what has been given to the private IP address space, which can be used for our traditional network in our enterprise and for creating virtual network in Azure. Who is going to decide on what private IP addresses has to be used in our private network is the IANA, which is Internet Assigned Numbers Authority. This is an organization which takes care of DNS IP addresses, etc. So whenever you create a virtual network in Azure, this is a virtual network. If you are creating a virtual network in Azure, and you have to choose either Class A and Class B or Class C IP address range for your virtual network. And if you are choosing any one of the range of IP addresses from these classes, you will be creating subnets. And each subnet will be reserved with 5 IP addresses. So if you are choosing any one of the IP range from one of the class, I will select class A. So I'll choose 10.0.0.0 network with CIDR block of 16. So I'll be able to create a subnet of 10.0.1.0 with 24-bit subnet mask. So I have broken this particular bigger virtual network into smaller networks. So from the available range of IP address from these total 65,000 IP addresses, I am breaking into 255 IP addresses for each subnet. Again, for IP addresses 0 to 255, you will be having some reservation of the IP addresses which we have seen. So Azure will be using 5 IP addresses. From these IP address, it will have 5 IP address reserved for their subnet. For each subnet, there will be a reservation of 5 IP address, and this will be 2.0 network with /24, and this will be 3.0 network with /24, like that. So like this, I can go on creating the subnet from this virtual network, and total of network what I can create, because I have used /16 subnet, which is the subnet mask which I can use for class B. So total of 16,384 networks I'll be able to create, and I'll be able to assign these many IP addresses for my virtual machines. Let us see using the subnet calculator. Because I am using this particular range for the virtual network, I will be able to see how many number of IP addresses I can assign to the host. So total 65,536 I can assign to the host in this particular virtual network, and usable host is 65,534. Because we have also broken this bigger virtual network into multiple subnets, each subnet will not have these number of usable hosts. It might differ in the Azure virtual network. If I enter this for the subnet, whatever I have created, for example, for the subnet 1, if I use /24, then I have to use the 24 range and calculate. Now you will be able to see the IP address for the subnet which I can use, and the network address which will be reserved, and this particular broadcast address which will be reserved for each subnet in Azure virtual network, and the total number of hosts for which I can assign the IP addresses, but usable host is 254. Even though I will take this 256 IP addresses, total number of hosts which I can assign the IP address, out of these I will have 5 IP addresses reserved in Azure Virtual Network, in Azure Subnet actually. So subnet mask will start with this subnet mask, because even though we are assigning the IP address from the class A IP address, since we have broken the virtual network into multiple subnets and we are using /24, that is the reason we are going to use this particular subnet mask. And it is also given the subnet mask in binary, and if at all we are using the CIDR notation, then it will be /24 for each of the subnet, which we have already seen. And the class range is class C. So that is why I said, even though we are using the IP address range from the class A, since we are using the notation of class C /24, the IP class will be C. If you see, I have been using the binary addressing for the IP address and the subnet mask. If I am using the default subnet mask for any IP address range, for example, this is a class C IP address. If I am using 255.255.255 and .0 for addressing this particular IP address, then this will be a class full IP address. Since this is a binary format, I have to address in a specific way. So if I wanted to address these binary bits, I have to do some calculation, which is, if I wanted to convert the binary into decimal, then I have to do some calculation, which will be 2 to the power of 0. For this bit, I have to use 2 to the power of 0. It will be 1. Then I have to use 2 to the power of 1, which will be 2. For this bit, it will be 4. For this bit, it will be 8. For this bit, it will be 16. For this bit, it will be 32. And for this bit, it will be 64. For this bit, it will be 128. If I add all these decimal numbers, it will become 255. It will be 255. Let us say, for example, if I wanted to have less IP address within the class C range, and I wanted to use these 2 bits for the network part also. So instead of writing /24 for the default, I have to use /26. So since these 2 bits are now used for the networking part, and I have a limitation of IP address now. So the total number of IP address what I can have after reducing these 2 bits, 32 plus 16 plus 8 plus 4 plus 2 plus 1.